So we've talked about matrix addition, matrix subtraction, and matrix multiplication, and this turns the space of matrices into an algebra. And there are laws of algebra, just like we had an algebra with real numbers, right? So remember, in real numbers we have the associative law, the commutative law, distributive law, and a lot of these are gonna port over to matrices. But there's one very specific case where it'll break it down, and it'll break down very dramatically, and we'll emphasize this. And this is essentially the breakdown of the commutativity of matrix algebra. So first, the associative laws. So we have two associative laws. One for matrix addition. So we have A plus B plus C. So if we added A plus B and then C, that's going to be the same as adding A after we add B and C instead. And if we do matrix multiplication of A and B times C, that's going to be the same as if we had A and then multiplied by B times C later. We also have a commutative law. For addition, notice that multiplication is not in the commutative law. We have that A plus B is equal to B plus A. We can swap those. We also have distributive laws. And remember, distributive laws where you got, say, FOIL back in the day. That's where we got FOIL from. So the distributive laws are A times B plus C is equal to A times B plus A times C. And also we have it on the left as well. So A plus B, if we multiply on the right rather by C, then we get AC plus BC. Now it's just not the case that we have commutativity, right? In general, so this is important. So I can't emphasize this enough. Cannot be emphasized enough. A, B does not equal BA in general. That's just not the case. For example, so here's a really quick example why this is not the case. And only in very specific, certain interesting circumstances will this happen. So I'm going to multiply A times B, and A is going to be on a matrix 1, 0, 1, 1. So they're really simple matrices. But you'll notice they're kind of opposite each other. Well, what'll this give you, right? So we multiply this row by this column, and we get 1. We multiply this row by this column, we have 1 times 1 plus 0 times 1 is 1. We multiply this row by this column, and we get 1 times 1 is 1, plus 1 times 0 is 0, so we'll get 1. Here I get 1 times 1, plus 1 times 1 is 2. But what about B times A? So I swap the order of these things. So now I have 1, 0, 1 here, and now I have 1, 0, 1, 1. Well, right off the bat I get 1, 1, times 1, 1 is 1 plus 1, which is 2. Already we see the problem going on here. If we fill out the rest of the matrix pretty readily, we see that these things are definitely not equal to each other. Not equal to each other at all. The next thing we're going to talk about is the transpose operator.